Welcome to problem of the day 22. Find the reaction forces in the beam. So we have this beam here, point A and point B, and then 10 foot, 10 foot, and 5 kips. This is a pin support, this is a roller support. So we need to use our three equations of equilibrium since it's a 2D problem. So a pin has a force in the X, force in the Y, where the roller just has the force in the Y there. And then of course we have our reaction force, and then 10 foot and 10 foot. This is needed for the moment. So first we'll sum the moments at A so that these two forces are not applicable. So we're just solving for this BY force. So sum the forces in the A equals 0. So you have the negative 5 kips right here, because it's, if you put your finger here, this will rotate that way in the negative direction, since we deemed that counterclockwise is positive, clockwise is negative, times 10, because it's 10 feet from this point A, plus BY times 20, so BY is 20 feet away, and then BY will cause a rotation in the other direction since we set it upwards. You could set it downwards or the other way, but if you set it downwards it'd be negative, and then you get a negative answer, and then you'd know it would be positive. Would be going upward, like you would know it would be going upwards because you'd have to switch the signs since downwards was negative. So once we solve this, you get BY is equal to 2.5 kips. You can see the equation here, so you get 50 and you have BY times 20, so you just divide 50 divided by 20 and you get that answer. So now then we'll sum the forces in the Y equals 0, AY 0 equals AY minus 5 plus 2.5. So we knew this was 2.5 now because we solved for it. And then this is a negative 5. So 2.5 going upwards, 5 going downward. And then we don't know AY yet. So then we take that and move negative 5 over. And then you subtract 2.5 and then you get AY going upward equals 2.5. And then sum of the forces in X equals 0, so we don't need to solve for that.